Hi Precalc, so we're going to go ahead and we're going to start with talking about our circular trig functions. We're eventually getting to a unit circle, but not quite there yet. So for today, we're going to always assume that our angles are in standard position. So let's suppose you are given a terminal side of an angle theta in standard position, intersecting the circle at point P. This point has the coordinates x, y. So here's point P, and they have these coordinates x, y. So when we think about this this reference point, right, or this reference angle, we're going to think of it as a triangle that we go ahead and we're going to drop down here. So this is going to form a right angle, therefore a right triangle. And the opposite side of theta, or the opposite side of this triangle, has the length of y, because you'd be going up y amount. And the adjacent side has the length of x, because you're going over x amount. And then, of course, you have the hypotenuse of the triangle, and that happens to be the radius of the circle. So it is the radius of the circle, right? So all of these are the parts of our triangle. And in general, the length of the hypotenuse, or aka the radius of the circle here, is going to be found by r is equal to the square root of x squared plus y squared. And because it's a radius, we're going to always be keeping it positive, right? Okay, so therefore, we can look at some of our trig functions here. So an angle in standard position with theta as the reference angle in this case is going to have these relationships. And let's, of course, remind ourselves that, hey, cosine is going to be adjacent over our radius. Therefore, it's going to be x over r. Our sine is opposite over hypotenuse, so it's going to be y over r. Our tangent is going to be y over x, but we got to be careful here, of course, that x does not equal 0. Our secant of theta is now going to be our radius over x, and again, x cannot be 0. Our cosecant is going to be radius over y, now where y cannot be 0. And then our cotangent theta is going to be x over y, where once again y cannot be 0. So all of these are relationships that we're going to be using throughout the year, right? And we also know that our radius is equal to the square root of x squared plus y squared, like we just said before, and it's always positive. All right, so again, I'm going to say we're going to be using this relationships for the rest of the year. Now, if we think about all these things that we just said here, right, cosine is equal to x over radius, we can also think about solving just for x. And we would solve by x by multiplying both sides by r. And if we did that, we would get that x is equal to, push the blue here, x is equal to our radius times cosine theta. And also we can solve for y by solving for multiplying both sides by r and getting r times sine theta. And again, we got those from, I'll go ahead and highlight them right here, our cosine and our sine, and we just solved for our x and our y values. Okay. So given that sine of theta is equal to 5 over 6, and we're also working in between 90 degrees and 180 degrees, we're going to determine the exact simplified value for the other 5 trig functions. Now, in this area, sketches are your friend. I'm actually going to go ahead and get a little bit of a coordinate there. Okay, so sketches are going to go ahead and they're going to be your friend. Now, we know we're working in standard position, so I'm going to start here, but we know we're between 90 and 180 degrees. So I'm going to go ahead and I'm going to bring out my terminal ray over on this side. All right, so if sine of theta is equal to 5 over 6, we know that from what we figured out before, right, is that 5 is going to be our y value and 6 is going to be our radius value. So we have this point here, and we know we're going to be going up 5 amounts, and our radius here is going to be 6, or the hypotenuse of our triangle, right? And we're trying to figure out, hey, what is theta? Okay, we're also going to be talking a lot about our reference angle in this position. So the things that we don't know here, I'll go ahead and I'll zoom in, is that we don't know our x value, but we can easily go ahead and solve for our x value by saying that 6 is equal to, or 6 squared is equal to 5 squared plus x squared. So we have 36 is equal to 25 plus x squared. And we know that that's going to be minus, so 11 equals x squared. Therefore, the square root of 11 equals x. So we know that this side is going to be square root of 11. Okay, so now we have all the side lengths that we need. And, oops, sorry about that. So now we can go ahead and fill in the rest of our trig functions. So we know that sine of theta is equal to 5 over 6. We're also looking for cosine of theta. We're looking for tangent of theta. We're looking for cosecant of theta. We're looking for secant of theta. And we're looking for our cotangent of theta. All right, so cosine is going to be our 11 over 6. And then tangent, sorry, the other thing that I need to remind myself is that we're going in a negative direction. So take note of that, sorry. Negative 11, because this point is going to be negative square root 11, 5. So negative square root 11 over 6. Our tangent would be 5 over negative square root 11. And of course, we're going to rationalize this guy. So we get negative 5 square root 11 over 11. And then our cosecant of theta is 6 over 5. Our secant theta is 6 over negative square root 11. And again, we're going to rationalize. So we get that this is, actually I'm just going to take this back so I have room to work. Negative 6 square root 11 over 11. And our cotangent is negative square root 11 over 5. So, moral of the story is you're going ahead and you are solving for your missing side length, and then, just get this over, and then going, and then filling in the rest of your trig functions from there. All right, so part B here. Part B, we're determining the values of theta and our reference angle, right? To the nearest, and I'm not going to say 10th, we're always going to be working to our, to 3 decimal places. So we can go ahead and we can use our calculators, and we have the inverse of sine of 5 over 6. And if you grab your calculators, you're going to get that that is 56.442. All right. So we know that that's actually going to go ahead and that's going to be our reference angle that we're working with. So we know that our reference angle is 56.442. Now actual theta is, we're going to go ahead and we're going to take that 180 minus that number. So theta is equal to 123.557 degrees. Okay, so making sure that you're distinguishing between your reference angle and what actual theta is, depending on what quadrant it's in. All right, let's try that again with, given that theta is pi over 4, we're doing the simplified versions of our 6 trig functions. Once again, sketches are your friends. So I'm going to start here with a coordinate grid, and I'm going to draw our angle. So we have pi over 4. So we know that theta here is pi over 4. All right, so if it's pi over 4, we're going to go ahead and think about this in terms of some special right triangles a little bit. And we know that this would be a 45-degree angle, and a 45-degree angle would give us square root, we're going to hit square root 2 over this one, square root 2 for here, and 1 for here. So we have sine of theta is equal to square root 2 over 2. We also know that cosine of theta is equal to square root 2 over 2. And we have tangent of theta is equal to square root 2 over square root 2, which is 1. And then our other three is that we have cosecant of theta is equal to square root 2. Secant of theta is equal to square root 2. And our cotangent of theta is equal to 1. So again, you're just kind of making sure that you're going ahead and you're sketching your triangles and getting to some of their degrees. All right, so what if theta isn't in the first quadrant? We're going to go ahead and, of course, make sure, like we did before, is that the reference angle is going to go ahead and take over, but we have to pay attention to signs, right? Because we know that they change by the quadrant that we're in. So this is going to lead us to the trig functions that are positive by our quadrant, okay? So number one here, we're given that secant theta is equal to square root of 3. Now, I always kind of like to remind myself that also means that, that cosine theta is equal to 1 over square root 3. Just as a bit of a note there. And that's going to be positive, and we know that sine of theta is 0. Therefore, we're working in quadrant 4 because our secant and our cosine are positive, whereas our sine is negative. So we're going to determine the 6 trig functions of theta, and then also again determine theta to the nearest tenth of our degree. Sketching is our friend. So we know we're working in quadrant 3. So I'm going to have an angle here and another angle coming out this way. So we know that cosine is going to be 1 over square root 3. Therefore, I know my radius is square root 3. I know my x value is 1. And solving for my missing side length here, or for my y value, is that we're going to have the square root of 3 squared is equal to 1 squared plus y squared. 3 is equal to 1 plus y squared. 2 is equal to y squared. Square root of 2 equals y. So it's going to be negative square root of 2 because we're moving downwards in that tradition. And again, you kind of get that by thinking about what this point is going to be down here. Okay, so our trig functions, we have part A here. We're going to have sine of theta. We're going to have cosine of theta. We're going to have tangent of theta. And we are also going to have our cosecant of theta, secant of theta, and cotangent of theta. So sine of theta is equal to our y over our radius here. So we're going to get our negative square root 2 over negative square root 3, which is negative square root 6 over 3. Cosine theta is, when we rationalize it, square root 3 over 3. Tangent of theta, negative square root 2. Our cosecant of theta, negative square root 6 over 2. Secant of theta, square root 3, and again, that's the one we were given, and our cotangent of theta is negative square root 2 over 2. So of course I gave you guys in all the rationalized forms, but making sure that you're rationalizing your denominators. I'm just always highlighting the one that we get to. Other thing, just like we did on the other side, is that we are going to solve, not to the nearest tenth, but we are going to go ahead and we're going to solve. So we know that we could take our inverse of cosine of 1 over square root 3. Therefore, we know that theta, or we get that theta is equal to negative 54.735 degrees. But we want to go ahead and we want to put this in our standard position. So we're going to take 360 minus that, meaning that we get to actual 305.264 degrees. So just making sure that you're putting that angle in our standard position, because we're moving this direction. We're not just working with our reference angle there. All right, let's try a few more here. So we're given that tangent is equal of the theta is equal to 5/12 and cosecant of theta is less than 0. Therefore, we know that we are working in quadrant 3 here. So we know we're working in quadrant 3. Go ahead, make a sketch. And moving down this way. So we know that theta is going to be moving like this, and this is going to be our reference angle. So we know we're looking for theta in our reference angle, meaning that we're going to take tangent inverse of 5/12, and again, grab your calculator. That's going to give us our 22.619. But again, that's our reference angle. So that's what we know our reference angle is. However, we want to know theta. So we're going to take that number plus 180. So we're going to get 202.619 degrees. And same thing for this one. Given if cotangent is -1 and our cosecant is greater than 0, so we know that cotangent's negative, cosecant is greater than 0, hence we are working in quadrant 2. All right, we're determining the value of theta and our reference angle. Once again, I'm going to go ahead and just kind of sketch it for us. So we are saying that our cotangent value is -1, and we can actually do this part without a calculator because we know that -1 for our reference angle would give us pi over 4. So we know our reference angle is equal to pi over 4, but theta is equal to 3 pi over 4 on that one. So hopefully we're getting a little bit of better idea as to like how to use this in terms of a circle and working forwards and backwards from there. So heads up, just if a quadrangle is not on, or is on a axes, we kind of have to think about relying on our trig functions to help us. And again, just kind of relying on these functions that we talked about up here in these relationships. So we know that cosine is equal to x over r. We know that sine is equal to y over r. And we know that tangent is equal to y over x. So when we're thinking about all these examples, we can go ahead and start plugging them in. Sine y is going to be 0 over our radius, aka just 0. Cosine of 0 is going to be equal to our x value over our radius, and those would be just simply assuming our radius would be 1 here. We're going to bring that down just to x. And then we have tangent of 0. 0 over x, which is going to go ahead and be 0. So sine of pi over 2 would be y over our radius. And again, we know our y value here, though, is going to be, so our y value here is going to be the same as our radius. So we're going to go ahead and say that's going to be 1. Our cosine over theta is going to be 0 over our radius, which is 0. Tangent pi over 2 is going to be our y over 0, and we can't divide by 0, so that's undefined. Sine of pi is equal to 0 over our radius, which is still just 0. Cosine of pi is going to be now negative x over our radius, which is going to be negative 1. And then we're going to have tangent of pi, which is 0 over negative x, which is going to give us 0. And then 3 pi over 2, we're going to have negative y over our radius, which is going to give us negative 1. Cosine 3 pi over 2, 0 over our radius, which is going to give us 0. Tangent 3 pi over 2, negative y over 0, which again is undefined. Sorry, going back and changing this one thing over here, which is that we're going to actually say that this is going to be 1. All right, so heads up on these. As we are looking at this, we of course are looking at, hey, our radius value and our x value in this same position would be the same number, therefore it's going to reduce to 1. Same thing here, is that sine pi over 2, our y value and our radius would be the same number, therefore it would reduce to 1.